this is just going to be like a basic overview of Rust and some of its like fun quirks and just kind of like an intro overall to the language and some fun things you can do with it. So let's just kind of like dive right into the code, because that's the most interesting part. So I have this main class with a grocery list function. Now I'm going to, I think I might have messed up my code just a second ago, but I'm going to run this, and it prints out a bunch of errors. And how many items are in your list? 1, just an apple. And there we go. My list has apple in it. So let's go look at that code and kind of break it down a little bit. So we have items, which we're declaring as immutable so that we can change it, because in Rust, everything by default is immutable. So we've created these mutable structures, and for example, count, that's like when the user enters in how many items are in their list, we're passing a mutable reference to count, and this function readLine is then going to write to it. So looking past that part, I'm calling count.trim, trims the white space, parse turns it into a usize, which this is kind of an interesting type. So Rust has a lot of different like integer types, like pretty common with most languages. However, Rust is like very explicit about it. So this usize, like if you asked for the length of a vector, it would be a usize. And every index into a vector is also of type usize. And under the hood, it's just like some type of integer.
Okay. Do you ever get into situations where, like, if you want to use a plain integer to index into an array, where you need to convert it explicitly to a usize, or will it just let you throw integers in?
So the question is, if you want to use a plain integer to index a vector, do you need to like convert it, or will it like infer the type? Yeah. Rust doesn't do type inference. So I believe that if you just create like an integer, or like in Rust it would be like an I32 or an I64, it would be like, we can't use this to index an array, and you would have to like convert it to a usize. We can do some experimentation with that in a minute though. So anyways, this is just like some basic code that like goes through what the user is telling us. It's reading these items, pushing them to a list, and then at the end, I'm printing them out. I had this code which also like went through the list and printed them out in like a pretty way. But this does the job. It's kind of ugly, but it's fine. Let's break down what this does a little bit, though. This is kind of interesting. So this is a string formatter, and you may have seen something like this in Python, where like, you know, you have like an F string, right, and then these brackets, which you actually put like variable names in. However, with Rust, the brackets are like parameterized. So like the first item goes into the first bracket. And then this colon and question mark. Have you guys ever seen anything like this before? No? So it's like, I actually had to look it up today because it's something that I always just like copy and paste around, and I was like, what does this really mean? It's essentially like a little mini map function that knows, so like this mini map function, this colon, so like anything to the left of the colon would be like my argument, and then anything to the right would be like do this with it. So in this case, we have like one arg, and the question mark means print the debug flavor of whatever the items are. So let me show you what would happen if I didn't have this. So we run this, and at compile time it says, a vector of strings cannot be formatted with the default formatter. So basically, the Rust compiler is saying, I don't know how to print out a vector of strings. So what we want it to do is for every item in this vector of strings, print what like the strings debug default is. And debug is just like if I printed a string, what would happen? Let's see. How do you instantiate a string? These are the types of...
Could you just throw in a string literal?
Oops, why did I choose 5? Apple, pear, peach, banana, cherry. Yeah, so you can just throw in a string literal. A string literal, interesting fact, is an str.
Oh, so
And
it's not a string.
it's not a like string.
Oh, interesting.
Yeah, there's a difference. However, you can like go back and forth. Okay, yeah, so this is like the super basic application example. So there's like another level beyond this that might be a little interesting, and I implemented Mergesort in Rust. And Mergesort is one of the applications of Rust where you're like, this is probably not the greatest idea, because Mergesort, if you remember, Mergesort is like, okay, you take an array, you divide it recursively until you have like one length lists, and then you sort them as you like merge them back up the tree. So there's a lot of like data copying going on. So it can be a little bit messy. So this version of the implementation is like I'm not worrying about how much I'm copying data. I don't care. I'm going to be as inefficient as possible. And then I have another merge in place where I'm trying to be a lot more efficient, trying to reduce, like do as few of copies as possible. And that one is not currently working. So, but we can still like take a look at like how it kind of works a little bit. So basically, we have this merge sort function. It calls merge sort recursive. Oh yeah, I was going to show something interesting too. Let's call this merge sort function that is working. So we are going to create a vector of strings. And then we are going to call merge on my vector. And let's just say, for example, that this function, I know it takes a second parameter. This is just for example. Let's say it also, you need to pass in like the length of like how many elements is in your list. Like that's dumb, you wouldn't need to do that, but let's just say you do. Okay, so there are a few interesting things to unpack here, but let's just run this. This guy right here. So this is the borrow checker at work. So we just instantiated my vec, which is a vector. And I'm using this like vec exclamation mark, which is a macro that instantiates a vector and then appends all of these values to it. So we have a vector. I pass it in as the first argument, and then when I try it again, the borrow checker is like, but wait, you don't own this anymore. You just, gave it to this merge sort function, so you can never use this ever again. So these are the types of things that as you're learning Rust are so painful because you just have never had to think like this before.
This is very confusing. Yeah.
Like confusing about like how that, like
So
why?
Why did I already give my vector before I even finished?
like calling the function. Yeah. So, so the question is, it's confusing, especially because like the method hasn't even been like evaluated yet, right? Like we're still in the process of passing these arguments. And I think this is something similar to if you were at the talk earlier today, something similar to like if I assigned like anytime I even just like do a mini like assignment or anything like this, like my vec no longer exists anymore. And so yeah, you run into these like very confusing situations. And when I actually saw this earlier today, I was like, what? Why? Like, especially because of what you just said, like we haven't even called this function yet. So like ownership like seemingly hasn't been passed yet. But the borrow checker is able to be really smart, sometimes smarter than you want it to be. So like the horrible way to get around this is to just like clone it. Like, okay, like just pass a copy of it in. And then, yes?
Question, if you were to put that clone on the subsequent myvec reference, would it, but not the first one, would it succeed or would it?
It would not. I'm guessing. I could be wrong.
Yeah,
The question, yes, okay, better, that's sorry. The question is if I were to put the clone on the second myvec versus the first, will it succeed? Yeah, guesses?
No.
Yeah, I think it won't because that's also gonna be a borrow and it's already.
Right, like we lost control of it here, so we're not going to be able to own it there. Oh, that was my bad. Yep, same problem.
So what if you computed the length beforehand?
Yeah, I was wondering. I want to see if. Well, yeah, I want to see both.
Okay.
Because I was thinking the exact same thing. Is there a workaround?
Yep, so that works.
But you clone. But you get a clone in there.
Oh,
We clone
Thanks.
after computing the length.
yeah, yeah. So we're allowed to have as many readers as we want. So you're like allowed to read the data. However, we can only have one mutator at a time. So that's like one instance where this is just a reader,
I see.
and this is the mutator.
Can we go back and look at the signature of merge sort?
Yes.
I guess because that's the question.
So I actually don't even use this parameter at all. I just threw it in there so I could like, make a good story. But yeah.
So the argument it takes is a list, which is a vec I32. Does that imply that it's taking ownership completely because it's not a reference or a?
Yeah, if I wanted a reference, I would put, let's see, I do that here.
Yeah.
In this append function,
Yeah.
I take a reference to a mutable vector.
Okay.
And there's a difference between, in Rust, there's a difference between a reference to a mutable vector and a mutable reference to a vector. So like, let me unpack that a little bit more. A mutable reference to a vector says that you can like reassign, right? Like you could assign, take this variable and assign it to like a whole new vector.
Yeah.
And then a reference to a mutable vector says that I can actually change the vector.
That's the same as C.
Yeah, exactly.
Okay.
It's like a point.
Yeah.
Yeah. That's really cool.
So this is Mergesort. So we have this Mergesort recursive function. This is our base case, like when the lists are only one length. This is just computing the middle index. And then you.
Okay, maybe I have one other question then, and I don't know if we can look at this. So what is it about list.len that allows it to like not consume ownership, is that it has an annotation and its signature that says, oh, this is read only, and so it's safe to pass things into, basically?
So the question was, what is it about like list.length that makes it not assume ownership?
Yeah.
And I really 100% don't 100% know the answer, except that I presume it's really just like reading a property about the list. And so that it really isn't like, if you're not changing the data or mutating the data and you're only reading the data, then there's no need for you to like take a mutation, like a reference to a mutable structure in.
Cool. Thank you.
Yeah. So these are the same function that we're looking at, and this is merge, which is this guy right here. So this just takes like the left, the right, and then does all of this. I implemented this today. There's probably a better way to implement this, but it's been a while since I have done it. But essentially, you like do merge sort, and then when you have like appended all of the left elements, you just like push on the right at the end because they're already sorted, right? Like that's the shortcut you take. And this function is like the only interesting function, I feel like, because new is the new array that we're building, like the sorted array. And so this is something we already kind of briefly looked at, but append actually takes the right array and the right index, and then just appends everything onto the end of new. So it actually like mutates new. It doesn't like return a copy of new. It mutates it in place. And what's cool about this is unlike other programming languages like Python, when you're calling this function, you know just by looking at it that this function could potentially change your arguments, right? Like you can tell, like, okay, right, I don't care about right anymore, I'm passing it ownership. Right index, I don't care about that anymore, I'm passing it ownership. However, this new thing that's being called, like, is, actually like changing this argument. So that's like a safety feature, I suppose.
How do you know that it changes anything?
I guess you know that it could change it because when you pass in this argument to append, like you don't care about the first two things. And if you just pass new without this, running cargo check, which just runs the borrow checker, it says this function is asking for a immutable reference here. You need to pass it. And it knows that by looking at this method signature where it's asking for like a mutable reference here. Did that answer your question about how do you know? I mean, there's no guarantees that it's changing it. However, like you're aware of the fact that.
How do you define a function that does not, that guarantees that it will not mutate?
Yeah.
How, because you define the function merge with left, right, so are they mutating by default? Do you have to say something to tell it that you're not mutating?
So the question is, how do you define a function that guarantees it will not mutate the parameters? And the answer is exactly correct that this merge function does not mutate left and right because it can't. Like, let's do a little experiment. Hopefully this will fail, and I did just lie. Okay. Expected immutable reference found an integer.
Expected vector, so it's supposed to be appending a vector.
So maybe you just need to wrap 5 in a one-item vector or something?
Oh, maybe I'm using the wrong. Maybe I'm using the wrong function for append. Push. Yes, append probably like appends all the other elements of a vector. So, I mean, we could.
Changing this to mute left.
What?
It says in the error message.
Yes.
Consider changing this to be mutable.
Right. So the compiler is like pretty smart. However, like you may or may not want to actually change it to mutable, and like that's up to the programmer to be like, oh, I'm so glad that it caught me that I was just trying to mutate this and I really shouldn't be, or to be like, oh crap, the borrow checker sucks. I have to go and follow all these instructions. But
Should have said, consider reading up on functional programming.
yeah, there you go. Yeah.
So mute left is different than and mute left, right?
Yeah, there's a difference between taking a reference and a just like mutation, being able to mutate it. So let's see if we can get this to work. So I'm passing it in as mutatable. I wonder if I also have to declare it as, I probably also have to declare it as mutatable when I'm creating it. Append left not found in this scope. What did I do? Expected a type.
It's not a left colon mute, it's a mute left colon.
Thank you.
It wants you to say.
So like this variable is mutatable, not necessarily that the type is mutatable.
Yeah.
Expected expression. I thought, let's see. So maybe it will just know that left is mutatable from here. I feel like I'm hopping around really quickly.
Is that pass
Remove
recordings?
this.
These are pretty nice compiler errors, honestly.
So it's saying that this doesn't need to be mutatable, which I think it's wrong.
Function never used.
Oh, that's an error because of this. Like, here, let me. So when you import these modules, this is just how you import functions from another file. It checks those files too. And so because I'm not calling this in main, it's like, you're never calling this. But that worked. So even if I don't make this variable mutatable, if I pass it in and say that this function can mutate it, that's enough. Which seems a little interesting to me. I'll have to like look into why that is. Anyways, we are way over time. I could talk about Rust all day. This is a super quick glance at my implementation in Rust of something called Tau, which if you've never heard of it before, is essentially a graph database that Facebook made. Like, this is old news. This paper was published like 2013, but it's this graph database, and so this is my implementation of it in Rust. If you're interested in learning or talking more about it, like, I'd love to chat. It's also part of a paper that I was an co-author of at OSDI last year, which was essentially, we built a multi-tenant data store in Rust, and it was really, really fast. So it was pretty cool. Yep. Anyways.